Welcome to the botiss podcast. I am Jacek from botiss, and today I am here with a very special guest. Usually he's very, very busy, so I'm very happy that today he took the time to be here. So it's great to have you here. I'm here today with Dr. Benno Buchbinder, who is the Managing Director of botiss Biomaterials. So today we are going to talk about product safety, about biomaterial safety. This has always been a very important topic, of course. And right now we are recording this podcast in July 2020. So we are still in the middle of a global coronavirus pandemic. Many people are asking themselves also about safety in terms of coronavirus. So, Benno, let me direct this question directly to you. At botiss, for example, there is the Maxgraft line, which is made out of human bone, allergenic bone. This bone is derived from humans. Now, humans, of course, they can get coronavirus. So, you as a biologist, what would you say? How can it be assured that there are no viruses, no coronaviruses in Maxgraft's biomaterials?
Hi, Jacek. Thank you so much for inviting me to do this podcast with you. Regarding the safety of bone grafting materials derived from human tissues, there's a lot of aspects that need to be taken into consideration. Due to the high focus on transmission of viral diseases at the moment, every local authority has set up a certain set of measures to maintain the safety of human-derived products, be it blood products, be it tissue products, or also solid organs that need to be transplanted. Nevertheless, so we can't stop transplantation of human materials in times of the corona pandemic. So for products that are not processed, there's a set of measures that are set up in order to exclude a certain population of potential donors. Some countries have set up rules that the donors must not have contact to confirmed corona disease or corona infected patients. Some others have set up measures that the donor was not supposed to travel within 28 days prior to harvesting of the blood or tissue products. This being said, those measures are set up for blood products, are set up for tissue products that are not chemically processed. So when we talk about Maxgraft, we are talking certainly about a product that fulfills highest safety measures or criteria in terms of a series of potential diseases, be it viruses, RNA viruses, DNA viruses, bacteria, but also fungi and spores. So the measures that are taken anyway, starting from selection of potential donors to the chemical processing up to the terminal sterilization, ensure that a series of certain pathogens are effectively inactivated, including the coronavirus.
Okay, so if I get you right, in the world there are two different categories, let's say, of transplants. Ones that are not treated or that are not processed before transplanting, such as blood or such as maybe a heart or a kidney. And then when we are talking about biomaterials, such as Maxgraft, in the case of Maxgraft, we have a processing process or a chemical processing. Can you tell us maybe a little bit more about this process or about this chemical processing process?
I'd love to, Jacek, definitely. So whenever the chemical processing is considered, we need to make sure that the reagents penetrate into the depth of the tissue effectively. So with a processing of max graft, it all starts with grinding the femoral heads, for example, when we talk about living donors, in order to make sure that the diffusion distance, so the way that the chemicals need to penetrate into the tissue, is not very long, so that even in the middle of the particles or of the blocks, the chemicals can effectively inactivate potential pathogens. So after shaping or grinding, there's an ultrasonic bath or ensuring the removal of fatty tissue, but also of blood components and also cellular components, before a series of chemical reagents are employed in order to disinfect the tissue. Especially when talking about potential transmission of coronavirus, it's important to mention that some chemicals are effectively used to disinfect surfaces that are used to disinfect other materials that might transmit coronavirus, such as ethanol or hydrogen peroxide, are essential components of the allotech process that is used at the CTPA. So whenever you have a surface that you want to decontaminate, you use a disinfectant mainly containing ethanol, for example, or hydrogen peroxide, to spray it on the surface and wipe it off. When we talk about max graft, we have those solutions, and the tissue is being immersed into those baths, ensuring a way longer presence of the tissue inside of those chemicals. So the contact time of the chemicals to with the tissue is way longer compared to effective surface decontamination.
Okay, so in the case of max graft, if I understand correctly, we have a very complex, very thorough production process. Now, max graft is a allograft, as we already mentioned, so it's a human bone. What about other biomaterials? So the most common used biomaterial in Western Europe is bovine bone. So in the case of botiss, it would be sera bone. How does it work with sera bone? How is coronavirus safety being assured there?
Again, there's a series of different aspects that are taken into consideration, starting from the sourcing of the tissue. So the herds of cattle that are used for the production of sera bone are a controlled population, so they are veterinary controlled, they are destined for human consumption. So all those safety measures that are valid for the human food processing is also valid for the medical devices, and vastly exceeding those even. Every step of harvesting of the tissue, from killing of the animals, from raising of the animals, to harvesting of the tissue, is tightly regulated and controlled in standard operating procedures. So this is the first thing, the sourcing. The next step is the processing, which is quite unique and not standardized when comparing materials that are derived from the same source but from different suppliers. So every supplier has a very specific protocol how to ensure that the effective inactivation of potential pathogens are met, that are given from the regulations. When talking about sera bone, we have the most sophisticated and the most safe way of processing bovine material, as this is not a chemical processing compared to max graft, but as a physical process. So the material is heated at certain stages and certain durations. It's a quite complex, very long protocol that completely eliminates all organic matter inside of the bony structure. So First, of course, when you start heating the bone, the water evaporates, then you get a elimination of organic components, and in the end, you even have a change in crystallinity, which is the reason for Cerabone being so stable even in the long term and providing long-term stability. So this is not just putting Cerabone in the oven, but it's really a complex process that is staged just to make sure that the physical structure, or in the macrostructure, the microstructure, and also the nanostructure of a material is not melted as assumed by every once in a while. But this is really a process that is so sophisticated that it maintains the structure and the porosity of the particles.
And you mentioned the heating. How hot does it get?
So the heating is exceeding 1200 degrees. And the reason for that is that with those temperatures, even inactivation of prions, which are known to be extremely stable, are eliminated. So with the prions that are usually transmitted by transfer of neural tissue, there's actually two ways to avoid any transmission. First is, of course, selection of cattle that is known to be raised at prion-free populations or countries, for example, New Zealand or Australia. The other way is to employ a processing that, even in case of a transmission, will guarantee that no prions will survive this process and can be transmitted.
Okay, so 1200 degrees you mentioned. It sounds like, this temperature basically inactivates and kills anything that could potentially cause any harm, like viruses, bacteria, and prions. Now, there are doctors there are voices that are suggesting that in times of the coronavirus, or also in general, it would be a very, very safe solution to use synthetic materials. What do you think about that?
Considering the potential risk of animal or human-derived products, with most products there's a theoretical rest of any transmission. That being said, this refers mainly to diseases that are maybe not known yet but will be detected in the future. When talking about Cerabone, this is a process that really eliminates everything. So whatever pathogen might be detected in the future, the process that is used to produce Cerabone will certainly also inactivate those pathogens. Yeah.
Mm-hmm. Okay. Now, the company botiss also offers a range of collagen products, such as Mucoderm or the Jason membrane or Colprotect. Now, those products being made out of collagen, I assume that they cannot be heated to temperatures of 1200 degrees. So, how is product safety being assured in those cases?
You're totally right that the collagen-based products cannot be treated by those high temperatures that are used to inactivate potential prions in Cerabone. Similar to the Maxgraph products, we use a wet chemical process for disinfection and decellularization of the collagen-based products. That is derived from dermis or pericardium of pigs. So we don't have a bovine origin, but we have a porcine origin. So transmission of prions is less a risk compared to the bovine products. So again, there's a series of different solvents and also hydrogen peroxide that is used to eliminate any potential pathogen, including also RNA viruses such as the coronavirus.
Now, with the coronavirus, we have seen that it can happen that new diseases show up, like diseases that have not been known before. Are there any measures that can be taken or that are being taken to assure safety in biomaterials against diseases that maybe have not been discovered yet?
This is a very good question, Jacek. And indeed, the safety or the risk that is associated with a human tissue or animal-derived products regarding detection of new diseases is a very essential step of the quality management process. So the risk level globally is always detected and updated every year, and of course consecutively in order to make sure that new risks are also appropriately taken into consideration for the safety of the products. So whenever there's a new disease that is found or any suspicious accumulation of findings, be it animal diseases or human diseases, we perform a risk assessment and checking how our process is eliminating those potential threats or not. And in case we find that some measures are not enough, of course, those will be increased and the production process is streamlined appropriately.
Okay, wow, this sounds very sophisticated. So in addition to all of those very thorough, multi-step security processes that are already in place, there are even protocols to protect yourself against diseases that may not be known yet. So this sounds very, 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 very fascinating, very amazing, and also very safe. Okay, so thank you very, very much, Benno, for having taken the time to do this podcast today. I think it was very, very interesting for our listeners also to see the biological backgrounds of the production processes. So thank you very much for having participated.
Thank you so much, Jacek. Have a good day.